For this episode of WDD's Hot Seat, we are speaking with Steve Laya, who has been Elite Sales and Marketing Manager for over 17 years. He has worked throughout his career helping Elite clients through the conformity assessment process for various regulatory requirements such as FCC, Industry Canada, and the European Union CE mark. In addition to his technical sales and leadership responsibilities, he also drives the development of new services for Elite. He is an internal auditor for the QA team and assists with the administration of Elite's ISO 17025 quality system and ISO Guide 65 certification systems. His specialized area of knowledge includes CE marking and international compliance regulations. Steve is a member of the IEEE EMC Society and the Society of Automotive Engineers. Steve, let's start out the conversation with you telling us a little bit about the new European Union requirements for wireless transmitters at 2.4 gigahertz.
European harmonized standard to evaluate wireless devices such as Wi-Fi, Bluetooth, and Zigbee transmitters. It's called EN 300-328. And this standard sets the limits and the test methods for transmit power, occupied bandwidth, spurious emissions, and several other technical requirements. The current standard is version 1.7.1, and it's being replaced right now, in fact, this January 1st, by a new version of the standard, which is called version 1.8.1. So it's going from 1.7.1 to 1.8.1. And it's this new version of 300-328 that includes some pretty significant different measurement processes, new technical performance requirements. That's what we're talking about today.
So what are some of the changes in this new requirement?
Right, yeah, one of the biggest changes is that the new standard now describes the process to evaluate a wireless transmitter's capabilities for spectrum sharing. So the 2.4 gigahertz band right now is already crowded, and it's the growth in wireless devices using these frequencies that's dramatically increasing usage in this band. So spectrum sharing is the ability for a transmitter to coexist with other transmitters in that space. So, monitor a particular radio frequency channel for other transmissions, and then to have the transmitter selectively choose to transmit on that channel or to change to a channel with less traffic or even reduce the transmit power level. So with version 1.8.1 of this new standard, transmitters with an output power of greater than 10 milliwatts, so that's 10 dBm, measured as an EIRP, so that's effective isotropic radiated power. So these transmitters must now use and demonstrate spectrum sharing techniques such as adaptive frequency agility, or demonstrate that they can reduce their use of on-air time by operating with a fractional transmit duty cycle. So just a portion they'll be transmitting for just a portion of the time. So adaptive frequency agility algorithms, these are these new features for transmitters that use listen before talk features that monitor the transmit channel for wireless traffic. So if a channel is occupied, then the transmitter algorithm has to detect and avoid the channel and move to another subband for continuing with transmissions, or it can also reduce its power, like I mentioned. So these capabilities for adaptive frequency agility are similar to CSMA, that's a carrier sense multiple access, or clear channel assessment features that may be inherent to more particular types of transmitters like Wi-Fi devices. Previous versions of the standard, for example, 1.7.1, they didn't explicitly evaluate transmitter operations for spectrum sharing. Rather it was the manufacturer's obligation to declare that the transmitter had some measure of spectrum sharing capability. So what's different now is that tests are required to be run to evaluate the transmitter's ability to share spectrum, not just the manufacturer's declaration. And it gets complicated too, and difficulties can arise with this technology. When you have to design and evaluate collision avoidance technologies that work with different types of wireless networks, such as a Wi-Fi transmitter interfering with a Zigbee transmitter. Again, there's different technologies there, so this new standard will evaluate the transmitter's capability to distinguish between those different types of transmitted signals, and again, determine if you have to move to a different band. And again, all of these requirements for spectrum sharing, they're limited for transmitters that transmit at a power, an EIRP of greater than 10 dBm. There are no requirements for spectrum sharing or duty cycle for transmitter operations for transmitters that operate at less than 10 dBm.
And what are some of the other changes?
Well, in the standard, what's new are some of the things that are going to change. You're going to see, a different way to measure power. That's maybe the first thing, and a pretty significant one too. To measure RF power now requires that you use a 1 megabit per second high-speed power sensor. And in most cases, power sensor instrumentation that may have been used previously in older versions of 300, 328, they're not going to be suitable for the measurements that are required in this new standard. And again, this is pretty significant because there's an entire market deployment of 2.4 gigahertz wireless transmitters, and these transmitters probably don't have a report that shows with evidence that the transmitter's in compliance with this new power measurement. They probably weren't measured in that way, so there's more than likely not a report that documents that. So what's certainly new in their power measurements, but power spectral density is going to be a different measurement as well. The power spectral density measurement technique now uses an RMS detector rather than an average detector that was employed in the previous versions of the standard. And in fact, power spectral density is normalized to EIRP. Okay, and there's a new measurement for EIRP now, so that's changed. And even the way that adjacent channel interference is now characterized, it is done with what's called a spurious emissions in the out-of-band domain. And this is basically an emissions mask that sets the limits for emissions immediately outside the transmit channel, but not yet into the spurious domain. And lastly, there's some other subtle measurement technology differences in this new version 181. So, we encourage manufacturers to look very carefully at the standard and just get familiar with the details in it.
So can you tell us how this will impact wireless manufacturers?
Yeah, manufacturers are the one that, they're ultimately responsible to ensure that their wireless devices remain compliant with the European Union directives. With each product shipped, they have to provide a declaration of conformity that states the equipment meets all the CE marking directives and regulations, and otherwise they risk non-compliance for use in the European countries. And non-compliance can slow market access, right at the point where the product's being imported into Europe, through customs. But it can also cause problems later in the distribution chain with retail businesses or distributors. We've seen where it's the retail business or even the major end user in the European Union that wants to verify the current declaration of conformity details before they make the product available for sale or will take ownership of the product. So we recommend the following for all manufacturers of any product going to the European Union, but certainly for 2.4 gigahertz transmitter manufacturers. At first, the manufacturer should confirm that the transmitter incorporates the technology required to meet the standard. This includes verifying the transmitter that it operates at that if it operates at powers greater than 10 dBm, that it's got this ability to comply with the spectrum sharing requirements, like adaptive frequency agility or using a fractional transmitter duty cycle. So make sure that you got the technology capabilities built into your product. The second step then is to confirm that your declaration of conformity references version 181 of this new standard, EN 300-328. If you've got a reference to EN 300-328 with an older version 171 or less, you're really not going to be in compliance. So check that. And while you're reviewing the status of your compliance with 300-328, take time to confirm that you're also listing the latest and current harmonized standards for EMC and for low voltage. as well as other CE marking directives like RoHS or possibly ATEX. Check all your directives. And lastly, make sure that you've got a valid technical file too that includes the reports, the documentation covering the new test. You've got to have a complete technical file with current reports to back up your declaration of conformity.
And for my final question, Steve, can you explain to us from an industry perspective some of the things that keep you up at night?
Yeah, I guess what keeps us up here a little bit is that we just don't want manufacturers to get caught without having a valid technical file, and then need to push their products through a compliance process at the last minute. With the deadline for compliance here, it's here. We're concerned that manufacturers won't have enough time to get their products developed and tested in time to meet their delivery dates. So that's a little concerning. What this new standard has meant for our lab is that we've had to acquire some brand new test equipment to make these measurements. In fact, the standard, it's caught the entire industry, the entire test industry, just a bit on its heels because the development of equipment and software to make these measurements was kind of late in being deployed and slow to being received by labs for use. So test labs are still having a hard time with delivery of this test equipment. So there may be a bit of a shortage of capacity to make all the necessary measurements for all clients. Here at Elite, we've got the equipment, we've got the facilities to perform the required EN 300 and 328 tests, per the new version 181, and we're working with clients right now to get their technical information updated and their products compliant. So, we're running our equipment continually, and we anticipate the volume of this particular test work will remain very high throughout 2015. Again, the deadline for complying with this new standard is January 1st, 2015. It's here, so we really highly recommend manufacturers stay connected with their technical resources, keep in contact with your test labs and those who provide guidance on your conformity assessment, and it's important to stay connected.
Well, I want to take this moment to thank you, Steve, for joining us on this week's episode. For WDD, I'm Megan Zimba, and we'll see you next time in the hot seat.